All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. We are, I guess, kind of picking up where we left off on the last stream, although I got a bunch of things done offline. We weren't online last week because of Thanksgiving here in the U.S., spending time with family, things like that. So I chose to take that week off, but the flip side of that is we did make some pretty serious progress. So that is all good. We'll get into that here in a moment. But before I do, I want to just take a quick second to thank the supporters of the channel, starting with our elite partner, Javier Lazaran, followed by our partners, Gabrali's Inc. and Matt Alsgaard. They are the highest tiers of subscription over on YouTube memberships and Patreon, followed by the list of supporters you see here on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for that support. It helps me a great deal and helps me cover the cost of running this channel, things like software licenses, hosting fees, and eventually asset generation for things I'm not capable of generating myself. So thank you all very much for that. It's going to go a great deal into moving this project forward. All right. Of course, I want to give a big thank you to you guys, the viewers, whether you're joining us live on the YouTube side or the Twitch side. We do simulcast both. Or if you're catching the VOD after the fact, thank you guys very much for being here, because without you guys, obviously this channel and this project would not exist. So thank you very much. All right. Looks like we got quite a bit of activity over on the YouTube side. Penguin Operator, actually, I see you're on both sides. I appreciate that. How's it going? Good to see you. OX Latorti, good to see you as well. Welcome.
I'm not quite
I hope you're, let me mute my Alexa because it, for some reason, picked up on that. All right. So yeah, welcome. I hope you guys are doing well tonight. Okay. So let's do a little bit of catch up. First thing I'm going to do, actually, before we get into any of the code, is I want to show you guys a visual result of where we're currently at. So I can load a scene, and I've got essentially this guy to be able to sort of walk around, right? So this is a free asset I grabbed off the internet as a placeholder, and this is what I'm going to use. For the time being, while we're fleshing out these systems accordingly, and then we are going to replace this guy with our own asset later, right? So I'm just kind of using him initially, and we'll see how far we get. Okay, so what we have right now is just the ability to sort of walk around, and it plays a walking animation as we do that. So you can see here in the console where we switch between walk and idle. So that was a basic system I was able to kind of get in, or I can't even really call it a system. It's more of a hack that I was able to get in offline, right? So we have that, and that is going to be the basis for tonight's stream, because we need something that's a little less hacky to actually handle this. But we do have the ability to walk around, and it is more than just a cube now, moving around. So it feels a little bit more like a game, as it were. So we do have still have the capability of, switching around between the editor and the game perspective. I did also get animated meshes working with the shadow map, so we can see here that we've got that working here over as well. And I did also a bunch of improvements, trying to sort of improve performance a little bit, and also fixing various build issues on macOS and Linux. So all of those things have been straightened out so that we're just a little bit closer to releasing 0.11 of the engine. However, you'll notice that tonight's stream is not titled after a engine episode. We are back into game mechanics, right? So we're going to be focusing on that for the foreseeable future. I don't think there's any other major systems that we have to put in place, and anything that we do have to put in place or bugs that we have to fix, we'll just kind of fix along the way. I see I've got some sort of artifact here in the shadow map I'll have to fix. But for the time being, we're going to be back in gameplay world here, right? So just as a reminder, we do have the ability to, walk into a sound effect area here, which is what that is. You guys can't hear that at the moment. And I also do have the hit shapes and the volumes working again. So you can see this text that pops up here that says travel to another Dingus test zone, press F. I can't do that at the moment just because that new test zone has not been converted to the new format, which should be simple enough. And then once we get that working, that should be good. But that's not really what I want to work on tonight. What I want to talk about tonight is sort of the player in general, and player states, and setting up some sort of state machine for the player, right? So right now we sort of have these two individual states, where if I'm walking forward, we have this walk animation that plays, and if I'm standing still, we play the idle animation. You can see those changing here. I don't have anything for backwards animations or strafing. That's just the limitation of the model that we have here. Maybe for backwards animations, I might play the forwards animation backward. And so we'll see about, setting that up, maybe using negative time scale or something like that. But that's the general gist of it, at least visually where we're at so far. Singy over on YouTube, good to see you. Welcome. My primary side is Twitch. Fair enough. Well, I appreciate the support on both sides there. Definitely helps the view numbers, right? Okay, so let's talk a little bit about how this is actually implemented. So we have this game on move forward, and we've had this for quite a bit. The main difference is that we essentially are going ahead and just playing an animation, right? So we already had this sort of movement code in place where we figure out what the walk speed is. We go ahead and we grab the transform, and then apply a forward momentum to that, set a velocity, and now we actually play an animation. And so this is kind of how we have that hooked up currently. Obviously, this is not ideal. It's far from it. And then we also have a new function down here, which is game on move stop, right? And then this essentially just unsets that animation, right? So it just changes it back to idle. And so if we look on game on move stop, essentially that is set to the release of these four particular keys, right? So the W, S, Q, and E. And actually this should probably, let's see, we do have strafing in here too, which I might actually remove strafing. Let's see, so A and D, those technically you'd probably want some sort of, if you're not moving forward, you probably want some sort of shuffle animation to go left or right. But we don't have those yet, so I'm not going to worry about that. And then Q and E allow us to strafe. So I'm actually going to disable those for right now. Because we don't have animations for that, and it just seems kind of wonky to have that. So we're going to say to do strafe animations, right? And so basically the way that this works is whenever we're in world mode, we have sort of these things set up here. Oh, you know what? There's actually, let's see, do we actually have the up and down keys? I don't think we actually have those set. Do we want to set those? Game on yaw. I guess I could have both, right? It's not as important, I guess. So the ultimate idea is what we want to do is take any of these things, any of these callbacks, right? And we want to convert them to essentially sort of an action. And that action will feed into a state machine that will change the player state. In this case, that just means changing the animation and what the player is doing, whether it's moving or not. So we kind of want to move all of that out of sort of this main area here, and we kind of want to take our player logic and move it elsewhere, right, to make it a little bit more convenient to work with. So what we're going to do is in the game lib. Let's see, we have systems. Where do I want to put this? Renderer. We could put it under world, but I don't think I want to do that. I think I actually want to do, I think we're going to start off with I think I'm going to call it player. Do we actually have, let me actually look at Illumino types real quick. Let me make sure that we don't have, so we have player state serializable, player frame state, player state. Okay, so these are things that we probably want to move, I'm thinking. So let's see. If we think about what the player is, right? There is a transformation, a model, which is the entity, right? Which I guess I should probably rename this to player entity. Then the entity, this should probably be, let's see, that should probably be player entity transform. So we have the player transform, player entity transform. What was the difference between those? Let's see. I just need to refresh my memory here. So Illumina entity player and then player, oh, right. We should probably actually solve this problem now that I'm thinking about it. So if we think about, and we said that this was going to be sort of a temporary thing. If we look at our zone configuration, right, we still have this in here, this sort of object in here, which is the player object as configured, right? So this is the sort of owning entity for the player, and we use this to move the player about. And then we have a model within that, and within that we have a hit shape, right? And so we can attach other things to this, other entities to it, and so forth, and that's all well and good. But I'm thinking at this point, we probably ought to make like a player type entity. And this is where we get into game specific entities, right? So player entity would automatically create this sort of outer entity and the inner entity for this player model, and then the hit shape, and eventually whatever else we have to put in here. And then we could remove this from the scene and insert this during load time, which I think would probably be the best way to do it. And then we wouldn't have to have all of this stuff sort of exposed in a global player state. It could kind of be more privatized, and we wouldn't have to worry about that, right? Spiro, good to see you. Fourth. Yep, you are indeed fourth. Third over in the YouTube side, yes. Dr. Elliott, good to see you as well. Welcome. Glad to have you guys here. All right. So if we start thinking about how we want to actually split this out, I think it makes the most sense to sort of have a, I guess what we could consider like a player structure, right? That then has state. And the reason that I'm thinking about that is because we might want to have, like the player state may have different data in it than just the player itself. Like we might have a world state, we might have like a inventory state, that kind of thing. And so this structure is was fine when we were scaffolding stuff, but I think we probably ought to think about replacing this with something. Also, this frame state is something that we could do away with as well. And then in game state here, we would just have like the player, right? So let's go ahead and think about how we want to structure that. So let's do, actually, should we do that first, or should we set this up in the scene to actually handle this the way that we need? I guess let's move around the player stuff first, because that'll give us a container for the new entity stuff. Okay, so type def, if I can spell it correctly, struct, and we're just going to say player, right? And in this, we're going to have Illumina entity, and this is just going to be the base entity, right? So we'll have that, and I don't know that we'll actually need the transform or any of that stuff. I think we can probably make the scene sort of manage some of that stuff for us. So what I'm thinking is, we have, actually, instead of doing this, right, instead of actually including it in the scene configuration, we do a scene spawn player, right, at a given spawn point, and then we basically create all this stuff on the fly. Maybe it would be better to do the player in the scene first. So let's go to Illumina scene. The more I think about this, the more it makes sense that we should actually probably split this out. So we have all of our entity types in here. And so we're basically just going to be adding another one. Let's see. So let's go to the bottom here of all of our entity types. I think I might have actually, yeah, okay. Let's go with, and actually, should we generalize this a little bit more? Because theoretically, like, we're going to have more than just one character on the screen, right? We're going to have the player, which has their own animations, their own model, their own states, their own whatever. But then we're going to have other characters as well. And then we're also going to have other, like, enemies, right? Which will also have their own states. So I wonder if I should put, like, come up with some sort of other name for this. So if we wanted to think of something that's a little bit generic, and I don't want to go too generic on this, but something that has a model, right, at a minimum, can have things attached to it, can move around on its own, something that could potentially have its own state, maybe something that has a subtype, right? So like maybe the subtype might be player or character or monster, right? And then those subtypes each have sort of different ways of handling things within themselves. What would we call that? I guess it would be a character isn't really high level enough, right? Because a character is sort of a subclass. Player is a subclass of this thing, whatever we're thinking of. I hate to use the term pawn, but I think Unreal might have actually got it right there. Um, what is another? You know what? Let me do a quick thesaurus search. Let's see. So there's some stuff popping up here. Security for a loan, no. That's not what we want. Person who's a fool, no. Does this really not have any better? Holy crap, this page is full of ads. All right, let's try a different one. Let's look up. So I guess we would have, let's see. Stooge. That's funny. That might actually be a funny way to implement it. Let's see. Minion, lackey, instrument, cat's paw, patsy. Tool doesn't seem right. Puppet. Minion seems wrong. Creature, maybe? Creature's not terrible. I would think of a creature as sort of a subcategory, but creature might work. I guess we could go with creature for now. What are you trying to think of a name for? So I'm trying to think of a name for something that exists in the world that has a state of its own that may or may not be controlled by AI or by the user, right? So it would be something like you would have various subclasses of this thing. So a player would be a subclass of that, right? Which would have its own model representation, like 3D representation in the world. It would have its own animations, its own states that it could be in, running, walking, idle, jumping, attacking, etc. And then you might also have like a character, like an NPC, that would be a subclass of this thing, which might have its own states that are different from a player and has different capabilities of a player. And then you might also have something like a monster, which again would be different from a player or a character. It would have its own sort of subset of states. Those kind of things. I just can't think of the dang word that I want. Like pawn kind of does it, but it just feels... Creature, I guess, is kind of the closest thing that I can think of. Let's see. Organism feels too scientific to me. I'm not going to think about this too long. I'm just looking for agent. That's not bad. Individual, maybe. Yeah. Let's see what's in here. Similar. Life form. Life form, right? Person is not really, that's too specific. Avatar. Avatar actually makes the most sense. I like Avatar a lot. We're going with Avatar. Good call. It's an okay movie. Sarcasm, yeah. We're going to go with Avatar. I think that makes sense. So let's see. So we're going to have a type def. Type def. Struct avatar entity. Right? Avatar entity. So obviously base entity, base. And then we are also going to have within that, we're going to need a few things, right? So obviously the base covers our base transform, but we're also going to need a sub model entity, right? So Illumina entity model. And from that, we can extract the transform whenever we need it, as well as the model instance. So we should be able to get that relatively easy. And then I guess we have other things like all of them are going to have like a F32 movement, speed modifier, right? That's something that's pretty self-explanatory. We could say for avatars, do they all have health, anima, and stamina? I don't think they all necessarily need that. I think the only one that needs that is the player. So maybe we have something in addition to this, where we have type def avatar type. Oops, and that should be enum. Avatar type, right? And we can do avatar type. And then I guess we could do character is the first one. Avatar type player as another one. Avatar type. God, I can't spell type tonight. Monster or enemy. Monster or enemy? I guess enemy kind of encapsulates monster. So we can just think about that for now. And then here, we can also have an avatar type. And we can do type. Right? So depending on which one of these types it is, we can then go into a different subroutine for how it's actually managed. A dingus. Yeah, right. The problem is if I put dingus into the code base too many times, we're not going to know what a dingus actually is. You probably would have won that though, yeah. I mean, I suppose we could call them dinguses, but or dingai. That's a little less, it's a little less descriptive, I guess, but I don't hate it. We are going to have mobs called dinguses though, or dingust type of enemies. My wife actually came up with a term the other day, stingus, which is going to be like, I'm going to use that as like a scorpion type, like a dingust scorpion or something. Just had a most fun evil idea ever. Next time you get forced to pair program, insist that you two should practice taking turns writing every other line of code. That sounds like hell. Dingus enemies, simply incredible. Yes, we are going to, actually, we do have, pull up the old design document. We do have, sorry for the flashbang. We do have a dingosaur. So that already exists. So the stingus is going to be in there along with it, right? We'll just have to come up with some art for that. But yeah, so dingosaur actually exists. And it looks cute and it looks cuddly. And the amount of damage it's going to do is going to be ungodly for the lulz. All dinguses are dinguses, but not all dinguses are dinguses. Dinguses or dingai? That's the question. Can just imagine a condescending no, put an open curly bracket. So what? You write next? Yeah. Yeah, I know, right? It would devolve into syntax wars for sure. Will physics be implemented next? We do not need physics for this game, so I'm not going to be putting it in. We're going to use, we're going to essentially use nav meshes or something similar to nav meshes to navigate throughout this game, but we don't actually need real physics simulation for this game. Everything can be sort of faked. A full-on physics engine would be overkill for what we're doing with this game. All right. So, I guess the question is, we have these avatar entities, right? So, they're always going to have a model. They're always going to have a current animation name. And they're going to have some sort of state, right? Which is ultimately what's going to be kind of what is driving the decisions we're making in this particular episode. We're going to have some sort of state machine for each one of these things, which makes me wonder how this should be configured, right? Because if we think about the level, right, we want to do away with this, right? We don't want our avatars in here. So it's almost kind of like we need some sort of separate avatar configuration for all of our avatars, because if we think about that, we'll need one for the player. And that'll tell us what model do we use, what animation do we default to, and then how do we set up our states, etc. So maybe we also have something that this can use when we're creating that, right? So maybe we have a new type of asset altogether, where we have a new asset category. So we can just say here, right, we create avatars, and then we can create a new file called player Illumina avatar? I don't know. That seems kind of a strange extension for it. Maybe we don't have a fancy extension. Maybe we just do Kaysen. Good enough. Let's do that. All right. So in this case, we might have a name for the avatar, right? So this could be player. And then we'll also have a model name, right, which is going to be taken out of here. So we want both of these actually. Right, so we have asset name, we're going to call that model name, and then package name comes out of Shadows of Illumina. That makes sense. And then we have, let's get rid of that Explorer. Let's see. I guess we should do probably something like model transform, right? Which would be this, actually. So we can actually just model transform, model package name, right? So we have that. This level transform we don't actually need. That is going to happen during the spawning, so that doesn't really matter. And then children, the hit shape here, I feel like doesn't really matter. We could just include that like I guess we could do hit shape type, right? And we'll do sphere. Hit shape radius equals 1.0. All right, and then what we can have as well is the states, and this is where things get interesting, right? So states is going to be an array, and for each one of these things, we're going to have a name, right? So we might have state is going to be idle, and animation name, which actually is, I copied these all out of here from the console. So we'll do animation name is equal to, and we're just going to grab this, right? So the idea here is to make this all configurable so that we don't have to recompile every single time we want to set one of these up. So animation name would be that, and then we can do something interesting here, which would be function name, right? Which would be player state idle. Player state, let me think. We would probably need on enter, right? So enter. And then on leave and on tick. And so this would be, this would actually be the name of a function that we could then use our already existing logic to load functions by name. We could load that from the game DLL directly and obtain a function pointer. So whenever we go into this state, we load a function that is called this. That would have to meet some sort of interface. And we assign the function pointer at that time. And then whenever we enter this state, this one would be called. Whenever we leave this state, this one would be called. And then for every update in the state, this would be called. And all of them would be optional. An animation name would also be optional, because you don't necessarily have to set an animation for some things. And then all of these functions could then be used to set internal state of things like, how much we're moving or something like that, right? So if we had an example of another state, we might have something like, let's see, this is going to be, I think it was walk. Yeah, walk. Right, so when we enter the walk state, we would turn the animation name to walk, right? And then this would also be walk, right? We don't necessarily need all those function names, right? But then we could also do this we could also use this to set other properties as well. Well, I think I'm going to hold off on that for now. So we have idle, walk. Let's put one more in. Let's put running in. right? So we'll just say run, because I think we do have a run animation here, right? So we'll say run, and then we'll do that, right? So these are the states that we can be in. You know what? Let's do one more state, because there's one more kind of thing I want to think about. And so let's do, let's see, attack. Let's do two more states, right? So we'll do attack sword, right? And this is going to be, actually we'll do, I guess we can do three more, right? So sword slash, right? And then here we could do attack sword. Actually, you know what? We don't even need these. Because what we can do is we can actually just generate those based off of this and say, if it exists, load it. If it doesn't exist, forget it, right? So we can set the animation name there. So that's attack sword. If we have a sword equipped, that's what we would use. And then attack unarmed would be punch in this case. And then if we were, let's see, I thought I saw one more. Shoot one-handed, sure. So we'll do attack ranged, right? Shoot one-handed. Okay. So those are the various states that we're going to have. Obviously, I can add more, but this is just to kind of illustrate some points, right? So idle can be gone to from any stage. Walk can be transitioned to from idle. Run can be transitioned to from either walk or idle. And my thought is that attack, any of the attack states, you have to be standing still in order to do those things. So we're like running attacks is not going to be run to walk to. Yes, exactly. Right. And so we should probably have some sort of definition here for what is allowed. And we're going to call those transitions. Right. And so the way that transitions are going to work is we're going to have a, well, I wonder if I should have this. I could do this as part of the state definition, but I don't think I'm going to. I think what I'm going to do is have a 2 equals idle. And then from equals an array of things, right? So we can go from walk to idle. We can go from run to idle. We can go from attack sword to idle. Attack unarmed to idle. Attack ranged to idle. And so we can actually transition to idle from any of these things. So essentially what we would do is we would say, when we want to transition to idle for some reason, what state are we currently in? Is the state that we're currently in this list? If it is, we can go ahead and do that transition. If not, we should probably throw some sort of error because our game logic is wrong, right? And so if we think about this one step further, and this is why I was thinking maybe I could add this up here to just the states themselves. Maybe I should do it that way. Yeah, let me try it that way. Let me try it. Let me take this. and do that, right? So you can transition to idle from any of these states. Maybe that makes more sense. And then, so walk, transitioning into walk, can only happen from a few different states, right? So we can only transition to walk from run, from idle or run. I think that makes sense. We're also going to have a jumping state, so that's going to be another thing. So we'll have to figure this out, a little as we go on. I just kind of want to figure out how we want to define this for now. So running can either come from idling or walking, right? But nothing else. And then attacking sword, right, can only happen from idle. Same for attacking unarmed. Same for attacking ranged. Those are the only ways that you can transition to those states. I think that makes sense. So if we wanted to talk about jumping for a second, I suppose we could put that in here too. So let's put jumping in here. Jump. So there are two ways that we could think about jumping in this game. And I haven't really defined this in terms of mechanics yet, and I don't really know how I want to handle it yet. So I think what I'm going to do for right now is say jumping can happen from idle, it can happen from walk, it can happen from run. If we only want to allow jumping while standing still, which seems kind of pointless, we could then do that. But jumping is one of those things I haven't really decided if I want it, if I actually even want it in the game, other than just being able to jump around for no reason. I don't know that it's going to add a lot of value other than just being able to jump. But there we go. Let's see. So receive hits, death, like there's all sorts of things in here that are sort of things that we should probably think of, right? Let's see. I think this is probably good enough for now for us to at least get some basic stuff down. All right, so that is what our states are going to look like. And then for each one of these things, like I said, we can create some functions that are named. I think the way that this is going to work is we have name, right? So it would be, if I wanted a idle on enter, right? It would be player. It would have to be a function named player underscore, or I guess it would be avatar underscore player underscore on enter. And if a function with that name exists, it will be invoked. If it doesn't, it won't be. Thank you for the stretch redeem. Appreciate that. Monster, oh wait, I'm 5 minutes behind. What the heck? Minutes? Maybe it's the DVR thing that they added to YouTube. Roman General, how's it going? Good to see you. We are talking about essentially what amounts to a state machine, right? I'm actually thinking I kind of want to do this before the scene stuff, to be completely honest. I was thinking I should do the scene stuff first, but I kind of want to do this first. This is like a proper introduction to our game mechanics, right? There's one more thing that we haven't talked about yet, though. and that is transition between different states, right? So there may be a situation where we want to have a transition between state A and state B, maybe to play an animation, to indicate that you can't do anything else for that period, or maybe to sort of fake animation blending or something of the like, right? And so for an example, you might have walking, right? And then you have idle. And you might want a transition state like walk to idle. You don't really need idle to walk, but walk to idle will sort of prevent. Let me just run this real quick. And this is something we can put in afterwards, but you'll notice how the animation is playing here, and then when I let off on the key, boom, it just snaps to the next animation, right? And even when you start to walk, it starts to kind of snap, right? And so we probably need some sort of something in there to sort of determine how that should work. And so that maybe will be something that we add later, like transition states, which theoretically could just be states in and of themselves, right? Where it's a state that maybe looks something like this, right? So it would be walk to idle, right? And then maybe we don't have a specific animation name that gets set or something. And so you'd only ever come from walk on this one, right? So that's maybe something else that we could set up as well. I'm not going to worry about that too much right now, though. I think as long as we get some of the basics down, we can at least get player movement kind of working and acting as we expect. So let's see, does this cover everything? Do we need... So this is an avatar configuration. Do we need... I actually don't know if we need the avatar type, to be completely honest. I'm gonna try and do this without the avatar type and see how far we can get. Because I think with this level of configurability, I don't think we're gonna need it. Okay, so how then do we handle an avatar, right? What is an avatar? So an avatar is, among other things, an entity, but similar to how we have a model entity, an avatar is essentially an entity that contains other entities, right? So I'm thinking with this kind of configuration, we would essentially recreate this in the scene. And maybe we just go with the name avatar. Maybe we don't have that subtype. I think that's probably going to be what we're going to do. All right, so an Illumina scene. That actually makes the most sense. I'm going to get rid of this avatar type for now. I don't think we need it. All right. So if we take a look at the avatar entity, I think we should actually split a lot of stuff out of here and have the avatar kind of be mentioned or managed in its own system. I'm actually thinking. Like we might have an avatar system that manages avatars. And then similar to how we handle other entities, instead of doing this stuff directly here, we would go through the avatar system to do that, which the avatar system would, the avatar system would have to know how to communicate with the scene to get things like the entities that it needs, and transforms, hit shapes, things of that nature. So it's going to have some knowledge of that anyways. Is it better to just do the avatar management in the scene? That feels terrible. I don't think I'm going to do that. Yeah, let's go with an avatar system. So we have our asset here. Let's go here to systems, and we're going to add avatar system H and C. And I want to actually take, let's take zone system H. Let's close some of these other things for now. Let's see. And I actually kind of want to copy a little bit, at least, of how this is. All right, so we don't need, I don't think we need the BST. So we have a type def struct avatar here. Let's just actually get rid of all of this stuff except for the, no, we don't need that either. Get rid of that. All right, so this will be avatar. I don't think we need any of these function pointers. This will be avatar system state. And then we have zones here. We have avatars here, rather. Right, so avatar count and avatars, we don't need that. Lookup of, avatar by name. No, I think we're going to stick with an ID for this. I think that's fine. We don't need this current either. Right, so for now it's just going to have a list of those things. Configuration for a given zone. So we're going to need this to be avatar config, right? That's what this system is going to understand. So get rid of that for a second. And then the avatar system config, itself. And then avatar config. Actually, I don't even think we're going to need configuration for the system at all. So we can get rid of that. And then avatar system deserialize config. Actually, I don't feel like we need that either. Let's get rid of that. Avatar system initialize, shutdown. I don't feel like we need most of that stuff. Okay. So, avatar system states, and we don't have any sort of config, so we can actually get rid of that. And these callbacks, we don't need any of that stuff. All we need is that, right? Which means we can get rid of, I think, both of those things for now. Die Machine, how's it going? Good to see you. Last time I was watching you, you developed the engine. Now you're actually developing the game. That's cool. You reinvented S-Jason, it seems. Yeah, kind of, sort of. We did that as an exercise into like how you might come up with a storage format of your own. So it's somewhat similar. We do have some simpler syntax rules, for it. But yeah, for all intents and purposes, it's pretty close. It does allow for comments and things like that, which stock JSON doesn't, but we call it KSON. Let's see. Was a 2. Hello. I am doing well. Thank you for asking. How are you doing? Okay. So, we don't need this. Okay. So, our avatars, and this is going to be the actual representation of an avatar, right? So the actual in-world representation of the avatar. So this is going to have a few things. It's going to have a kname, obviously. Model name. It's going to have a kname, or actually kTransform rather. Default transform. Let's see, we're going to have a model package name. That should probably be up here. Let's put those together. So we'll have a model package name, so we know where that's coming from. So there's the default transform. And then as far as the hit shape goes, we should probably also have Illumina collision shape. There we go. Hit shape. So the nice thing about the Illumina collision shape, we created this on a previous stream, is it has the shape type here, which is either sphere or rectangle, and also has a union of a radius or vec3 extents there. So that will give us what we need there. Okay, and then we have the states, right? So this is going to be kind of what we're going to have. I'm debating whether to make this state machine stuff like super generic or make it specific and split it out later if we need it elsewhere. I think I'm going to go the specific route first. So let's make it bespoke, as it were. So I'm going to go with type def state, or struct rather. And we're going to call this avatar state. Right? And each of these is going to have a name. So kname, name. And a kname animation name. And then it's going to have a couple of other things that we briefly talked about here. So we're going to need a type def, and we're going to need a function pointer, right? So we're going to have return type void, and we're going to call this pfn, and we're going to do avatar on enter. Not on enter, on avatar state on enter. Yeah. And so that will take in the struct avatar for now. I'm gonna have to forward declare that. All right, so we have the on enter, and then on leave, and on tick. All right, so these function pointers will be optional for each of these states, right? And it'll be based off of whether or not they actually exist in code. And it'll be based off of the name of those things. So, in other words, We'll do on enter, and then we'll do leave, if I can spell it right, leave, and then tick, which I guess we could call that update. So that actually is probably going to need a little bit more information. Struct frame data for one thing. So we want struct frame data rather. Oops. Yeah, fine. P frame data. Sure. Okay. So this will basically be if there is a function called essentially avatar underscore avatar name underscore on enter, then this will be assigned. Right? So what this is going to do is it's going to allow us to basically say, without having to set up explicit function pointers or any of that stuff, it's going to allow us to hook these up simply by the functions existing. Right? So as long as they're named with that, right, where it's avatar underscore avatar name on enter, that'll give us that flexibility, right? Let's see. So we have the avatar state, and then probably what we should have, we do have the animation name, which part of me is actually kind of wondering if we should even have that. But maybe we'll come back to that. The next thing is we're going to have a void pointer. And this is going to be the actual internal state. Right? And we're going to have a U32 internal state size. Size. And the way this is going to work is going to be if there is a function. Why don't I just... If there is a function called avatar name, creates, then this will be alloced assigned, right? So if we have a, again, by sort of a naming convention here, we can kind of get this to do what we need to do. Note, there should also be a destroy to clean this up, right? And maybe we can throw warnings if that's the case. All right, so when we read in one of these configurations, we'll take a look at the name. That will tell us everything we need to create these things. And I think that might be it for now. Okay, so we have initialize, shutdown. We do need a void avatar system update. All right, so this is going to be avatar system states, and then frame data, p frame data. And that might be it for right now. We might need delta time and things like that. In fact, we probably will need delta time and stuff like that. But for now, that's all I'm going to add. And then one more, which is going to be avatar. Oops. We should probably have a B8 avatar. Create from config. Right? And the way that that is going to work is we'll do avatar system state, and const character array config string. Right? So we'll essentially read this entire file in as a string, and then this function here will deserialize that, create a new avatar. Then we also need a way to reference that. So let's do a typedef U16 avatar what do I want to call this? K avatar? That seems wrong. Do we want to go with the whole ID thing in here or not? Or do we just want a pointer to an avatar? Maybe we just do that, right? Maybe we just have... Maybe in this case, like since it's game code, maybe that is okay in this case to just pass pointers around. The low-level system stuff, I try to avoid doing that. But I feel like in this case it's fine. But if we're going to do that, the other thing we probably need in here is a U16 ID. Right, so we know what index it is into the internal states array of avatars. Okay. Let's see. How did you learn to create a custom game engine in games? Trial, error, experience, all of the above. Lots of practice. Reading up on existing game engines. I've done it professionally. Yeah, it's just it's a myriad of various sources of experience. Constantly struggling with pointers versus indices questions in my game code too. Yeah. So the lower level system code, I tend to like indices of things better. Because generally speaking, you need the data. It depends on how the data is actually going to be accessed and used, right? So the thing I worry about with this is anytime I access an avatar, I have to load all of this into the cache, right? Versus if it's ID'd, and then you can say, I just want the name for this particular ID, then all you're getting is this. Because internally you would have an array of all of these individual things, and then you could just get the thing. The problem is that becomes kind of tedious in game code to deal with. So I'm going to try it this way. And worst case scenario, I can refactor it the other way. And it's not too hard to switch over. We're going to see how that works this way and go from there. Avatar config, I don't think we need that. I think we can do away with that. Do we have any other... Okay, we got rid of all the zone nomenclature in here. Okay, so system startup and shut down, the on tick, the create from config, that returns a pointer. Okay. We are also going to need... We're going to need other functions for this as well, right? So we're going to need... I could have booleans here. I don't know if I'm going to keep this. Avatar... And I guess we'll do state. How do I want to do this? Avatar state transition, right? And so this will have probably just the avatar. And then the kname state name. Right? And so the idea here is that you would attempt to transition to the state with a given name, right? Which would be looked up here. Sorry, not there. Here. And then whether or not, this was valid or whatnot, or if it was able to actually make that switch, we would return here. I'm actually thinking, let's do void. And we'll just do a hard assert. Like if you try to switch to a state that you can't switch to, like let's just break our code, right? Because that'll make it super easy to find and track down where the actual problem is. And then we don't have error handling all over the place, which would be annoying. So, I suppose the other thing that we should probably do is we probably also should provide something that says avatar state can transition, right? And this would take a constant pointer to that. And so this would basically be saying, can we actually make this transition before we actually make the transition to the next state? Okay. I feel like on the surface level, that's probably going to be good enough. Yeah, I think I'm good with that. The only thing I don't like is like the problem with doing it this way too. And this is another thing where the IDs versus pointers kind of comes back, is if we have this exposed this way, right? And we actually did I not actually put, I didn't put states in here. What a dingus. Okay, hold on a second. There. Is the problem is you could actually have, let's see, I guess I need a U16. Do I want a current state IDX? Right, and we could also do it. Something like that. I'm not 100% sure about that, but the problem with passing pointers around, right, is like we have access to all this internal state, so the game code could screw with this, right, which isn't ideal, but since I'm the only one accessing this game code and it's not engine level stuff, I think that's fine. If this were a system that I was putting in the core of the engine, that necessarily wouldn't be fine, but I think that's fine in this case. I do worry about blowing out the cache with all of this data in here, but we'll cross that bridge if and when we come to it being an actual performance issue. Okay. So I think I have what I need here. So let's take all of this and go to avatar system. And we'll include avatar system.h and paste all this stuff in here. And of course, we need to fill all of these guys out. one more. All right. So initialization. Actually, I just realized I got that wrong, and this should be U64. Memory requirements, right? As with our other systems. And then we have the states. And then we don't actually have any config for this, right? So this is actually going to be okay. So all we need here is memory requirements is equal to size of avatar system state. And that is just in case we have some sort of external thing setting up this system for us, right? So if not states, that means we're just getting the memory requirement, so we can return true. Otherwise, let's see, states, avatars and avatar count. I wonder if we should just use a D array for this. I feel like doing this is just kind of overkill at this point. Right? Let's do that. So we'll do darray creates, and the type is going to be avatar, or just avatar. Okay. All right, and then return true. Okay. Now, this can be a sparsely populated array, which means that we may have avatars come and go, created and destroyed, but we don't want to compress or grow the array every single time that happens, right? We only want to grow the array, and if we have ones that get deleted, then which actually we don't have a function here for that, then we just basically free up a slot within the avatars array. That being said, I guess we could go by ID, right? So if the ID is if invalid ID U16, then the slot is free, right? We'll go with that. And then down here, let's see, we have create from config. We also need a way to destroy, right? So we need the, avatar. Right, so we need that. Okay. Initialize is good. Shut down. I'm going to put this as a massive to-do. Free all the things. All right. So updates is going to be an interesting thing. So essentially what we're going to do is do U32 counts equals length states avatars, and then loop through these. And then we'll say if, actually I guess we could do avatar A equals the address of states avatars sub I, right? And then we can say if A wait, didn't we? Didn't we set? Oh, it's for the state. It's the active state. Okay. So we're going to have to look first at if a ID equals or is not equal to valid ID U16, right? So we'll check that first. And then we can go ahead and look at a states sub a current state IDX. So if that on tick is set up, right? So we'll say if that exists, then we'll just go ahead and call it, right? And that's just going to take a, I think. And then, what was it, frame data? Why is this bleating? Extracts unexpected type name frame data. Oh, P frame data. There we go. Okay. Let's just fix that really quickly. All right. Actually, wouldn't have defines been included in the header? Yes. We don't need that in here. Okay. So essentially, the avatar system update is going to look through to see, do we have any, first off, do we have any avatars? Any of them that are currently active, does it have an on-tick set? If it does, go ahead and call it. I don't think there's much more that we have to do within the update than that. We basically just need to make sure that all of our avatars get updated accordingly if they have an on-tick set. All right, create from config. That's going to be where we read in this. So I suppose we probably ought to do that because the destroy is going to undo that. One thing we can do is we don't have this definition here. So I guess we can do U32 from state counts and then kname from states. Right. So when we do a can transition, we're going to want to do a I guess this is just going to be U32 count equals DArray length a states sub a current state IDX. Oh, I guess I actually just could use that. We don't even need to do this. That's not going to be a DArray. U32 count equals that. Right. So what we'll do is U32I equals 0, I is less than count plus I. And then if let's grab a convenience pointer here. So we'll do avatar state address of that. Right, so now I can just say state, oops, right, and now I can do if state from states sub I equals state name. Return true. Otherwise, return false. Right? And then in here, we can actually do a kassert message. And we can put in avatar state can transition. A for the avatar. Put in the state name. And then the message we want, state transition not valid. Right? And then we can do the actually let's just fill it in, right? So there's a couple things we're gonna have to do. Avatar states, we're gonna have to get the current state and the next state. So we'll say state is the current state, right? I just saw something I want to refactor, but I'm going to get to that in a second. So we're going to say if state on leave, then we're going to go ahead and call that state on leave, right? And that, I believe, just takes the avatar itself. I want to actually take this function out here and split it out. Static I32 get from state, right? And this is gonna be const avatar a and then kname name. Paste this here. And so what we're going to do, actually, is state name. So instead of returning true here, we're going to return I. And if we don't find it, we'll return a -1. Right? So what we can say here is return get from state a state name is not equal to -1, right? But that's going to allow me to get down here. What is our new state, right? So tell the old state we are leaving. Get the new state and announce arrival. Right, so states is going to be the address of, actually, no, let's do a current state IDX equals, cast that to U32, and we'll do get from states avatar state name, right? And then we can just do this again, right? We can just get that again, and then we can say if states on enter, then we can say states on enter passing A, right? And that is how we do that. At least for now. When we have transition states, there may be something that automatically happens there. But the nice part about this is if we have those transition states, we can actually set up functions in here that can invoke this state transition after a certain amount of time, for example, or when an animation completes or something like that. So this system still remains pretty flexible, even with that in mind. Okay, so now the meat and potatoes of things. We need to deserialize this guy. in order to give us a new avatar. I suppose the question is, how likely are you to mess up with your own dingusness on the pointer, or doing something weird, creating massive bloats via pointers? If you're less worried about it, then it makes total sense for a little bit of DX. Yeah, and I think this is one of those cases, right? Using your engine to make a game now, yes. Actually, we've kind of been doing that for a while. It's just we had to kind of shoot back to the engine, and I assume we're going to have to do that again, right? We're going to be going back and forth, but for the foreseeable future, we're going to be in game code land. And actually, we kind of technically have been for a little bit now. I guess wasn't completely naming the streams correctly because there were a couple of things I wanted to do, but yeah, we are firmly in game territory now, game logic. Okay, so the first thing that we have to do is we need to obtain an ID, and I'm going to actually make this one. I'm going to make this one a private, like a static function, because I suspect we may need this in more than one place, depending on how we create these avatars. So let's see, we have avatar. Let's see, I guess create new, right? We want avatar system state. And all this is going to do is stand up the sort of base avatar without all of this configuration. So what that means is we're going to do we're actually going to go through here, loop almost exactly like this. So we're going to look at any of these, but we want the invalid ID, right? If we find that, then we're going to say AID equals I, first off. And that's pretty much going to signal that we want to create the thing at this point. So at this point, we can return A. If we get this far, and we've not actually found a free index, that means there are no free indexes in the array, and we need to push a new one. So what we'll do here is we'll do avatar, new avatar, and we're just going to zero that out and do a darray push, darray, push. And so the array is going to be state avatars, and the value is going to be a new avatar, right? And then what we'll do is we will return the address of state avatars sub count. Because even though this count will be count plus 1, the count that we took here will technically be past the end of the array. And so that's actually what we're going to need. So the create new will either fetch us from an existing empty slot here, or it will go ahead and create a new one and push it for us. So that's the first thing we're going to have to do. So avatar A equals create new, we'll pass state. So that's the first step there. And then the next thing is going to be we're going to go ahead and parse the config. And so I think the best way to do this, obviously, is to start from the top. So we need kson tree from string. And the source is going to be the config string. And the out tree is going to be kson tree. And we're just going to call this root. Right, and we're just going to pass I guess I could call this tree. That's fine. So let's just pass the address of tree. Right, now, This returns a Boolean to indicate success or failure. So if this fails for some reason, failed to parse casein for avatar creation, see logs for details. And this is going to return zip. All right. So we've got that. Otherwise, we are good to go. So name is going to be a required field. So the way that we're going to have to do this is casein object property get string is kname. The object is going to be the address of tree root. The name is just going to be name. And then the out value is going to be the address of a name. Right? Now, if that fails, oops. We'll have k error. You know what? Actually, we should probably do a create from config cleanup. Should probably do this, right? So we'll do casein tree cleanup, address of tree there, and then we'll do a let's see. I suppose we should probably actually wait to do this until down here. All right, and then we'll indicate success up here. So we'll do B8 success equals true, and then down here, if actually we just do return success A, otherwise KNL. Right? So obviously if this fails, K error, property name is required. Right? And we'll just do function. Right? And then we'll do go to create from config cleanup. Right? Okay. Before I forget, right before our label down here, we'll do success. This should actually be true down here. This should start off as false. Right? So we're going to assume failure until we get all the way through it. All right, so if we have an error getting that, then we go ahead and spit out an error message, go down here, clean up, and then we're done. So this is going to be the same thing. We're going to need, all of our avatars are going to require a model name. So model name, and this is going to be model name, and model name is required. So that's going to be required. The thing that's not necessarily going to be required is the model package name, right? Because we can actually do a little bit of defaulting for that. So if that is not there, then instead of doing this, then we're going to do a model package name equals kname creates package name Shadows of Illumina. There we go. Right, this is game code. I'm fine with putting this in here. All right, so default to game package if not provided. Config. I don't think we're going to have multiple packages here, but we might. So we'll see how that turns out. All right. Model transform is also not something that's necessarily required. But let's see, how are we actually doing? Did we actually hook up anything for transforms? Did we actually do anything for transforms in... Didn't we have... I guess we don't have a separate serializer for that. Deserialize. Init base entity. Yeah, but where do we get that? Transform parent. There we go. That's how we did it. This is what I was looking for. Okay. That's the answer I want. Okay, so transform is optional. We're going to call this model transform. And so this is going to be model transform. And then the address of tree root is going to be the object we're going to extract that from. And then, so the way that we have to do transforms, if you don't remember, maybe I'll extend the case and format to handle this as well. But we go ahead and obtain the property as a string, and then we do a k-transform from string. And when we do that, we do it without any sort of user data, right? And then we go ahead and return that, right? If for some reason that fails, then we just go ahead and create a new transform with no user data. So basically it's like an identity transform. Or if it doesn't exist, we do that as well. You know what? I've had to put this hack in a couple places. I wonder if we should just extend the case and format while we're still here. Let me see. Oh, got some messages over here. Let me catch up. I have been locked in, yes. Could you show the game you're working on? Crazy function name. Does a case and system support UTF-8? Yes, it does. Yeah, I mean, I could. There's not really much to show at the moment because we've just transitioned, but as long as I didn't break it yet. I don't think I've tried to build, so you know, it's just literally like debug and test assets at the moment, you know, so it's like literally all we can do at the moment is walk around. So we're building a little bit of a state machine to assist us with this so that we actually have things in the world or things in our code base to make this a lot easier to manage. Because right now this is sort of just hacking things that we have through the scene to work together. So, Jeet, how's it going? Good to see you. I am doing well. Thank you for asking. I appreciate that. Not sure when you came in, but yeah, I appreciate you being here. I am too deep. Yeah, I was locked in for sure. Hydrate and posture check. Appreciate that. In a get stuff done mode tonight. You know what? I think I'm going to put this in. I think I'm going to extend our format a little bit here. So, our case and parser, I'm going to do it here. Vec3. So, not add. I don't want to add. Well, I need to do an add, but let's see. element value, object property. Okay. So essentially, oh, we already do have a mat 4. We can already do this with mat 4s, but apparently not transforms. Cool. Okay. Well, essentially, I'm going to take this and just roll it straight into the KSIN format. Which, as far as the format's concerned, it's still a string, but we can basically say, take this property and auto-convert it to a transform, so we don't have to do all this crap in user code. So I'm going to do this. I'm going to take this function here for the mat4, and I'm going to do a k-transform, right? And we're going to do k-transform here. Which means we don't actually have that, which means I'm going to need the system, oops. Sure. Okay. So the way that this is going to work is I'm actually just going to take all of this stuff and put it here, right? So we have our transform string. But I have some internal stuff that I can do. Get string reference. Target type. Did we actually even wind up doing anything with that? I don't think we did. That's funny. Okay. I guess the idea was to do that conversion here at some point, but I'm not going to bother with that for now. All right. So I guess we could probably just do this, right? Because this avoids a reallocation. So I'm actually just going to take this and I'll go ahead and do k-transform, even though that's meaningless at the moment. And then I can just do I want to have a default if it fails is the question. Or do I want to just bleat about it? If this fails, it just returns it as is. So maybe we'll just do that. Right, so I can put this here, return this, get rid of that. Oops, wait a minute. Let's see. This needs to be out value. And then this needs to be oh, shoot, this might actually be a problem. I might not actually be able to do this. There's something I didn't think about. This is in the core, and the transform system is in runtime, not the core. So I can't even do this right now. All right. I'm going to put a pin in that idea, because I do need to eventually do that, but need to incorporate this into KSIN, but the transform system is in runtime where KSIN is in core, right? So basically the idea here is that the KSIN format is in core, which only has a reference to itself, and the transform system is in runtime, which references core, but core doesn't have a reference to runtime. So we can't do that yet. It's fine. We'll move on. So I think this is fine, actually. So once we have the T here, we should probably actually do a default transform for all of these guys. Okay. That works. That's good enough. All right, so that's name, model name, package name, transform, hit shape, and hit shape radius. Didn't I do this already in the... Okay. Let's do... I think I can rip this code out of here as well. Here we go. Volume type. Here we go. Shape type, and based off the shape type, we have this. Okay. I don't know if we need, you know what? Hit shape tags. Do we need? I'm going to skip that for now. I'm just going to take this. Okay. So we're going to put this in here. And so this is going to be hit shape type, right? So this will be shape type, right? Will be that. This will be address of tree root. Should be able to have this. Really? Where is... Oh, it's here. No wonder it's not available. All right, I'm just going to do it. We really need like a utils file, but I'm just going to plug it for now. All right. Okay, so we have the hit shape type, and then based off of that, we don't need that. Based off of the shape type there, we'll either extract the radius or oops, this needs to be hit shape radius. Hit shape extents. There we go. What is this bleating about? Is this just, yeah, it's missing the math header. Okay. So that's those two properties. And then the last thing that we need to do is parse the states. So that is basically going to be an array that we have to iterate through. Looks cool already for a custom engine. I appreciate that. Thank you. Automod apparently ate your message, but yeah. JavaScript. That's funny. So the KSIN is Kohi Object Storage Notation, is what I called it. That's why I called it that. I probably need to write up a spec document on that at some point, similar to what we've done for the K3D model format, but takes time, you know? All right, so KSIN object array. Object property value get array. Yeah, okay. So we want from the tree root, we want to get states, right? And that's going to be to a KSIN array, states array. Right, so we have the address of states array. Now, if we think about this for a second, we probably don't want to allow an avatar that doesn't have any states. So if this fails to be found, why are you trying to create an avatar with no states, you dingus? Go to create from config cleanup. All right. If that's found, then we need to do a KSIN array element count get, right? So the array is going to be the address of states array, and the out count is going to be U32. Actually, I think we can just do a state count. Yes, we can. So we'll do address of a state count. And again, if this fails, in fact, you know what? I'm just going to assert this. Because if that fails, like if we get this array, and for some reason we're not able to successfully get the number of array elements that are in this, something's gone horribly wrong. So we're just going to assert at that point. And then here we can do a for u32 I equals 0, I is less than a state count plus plus a, right? And before we do anything else, we can do a states, and that's going to be avatar states. We'll do a k alloc c array, avatar state is the type, and the count is a state count, right? So we have the array there to write into. And then we can go through here and extract this thusly. So first thing we're going to want is name. Let's see. Name is going to be required. Actually, we need to get the object itself first, right? So KSIN object, and we're going to call this state config, right? And then we'll do KSIN array element get object, right? So we're going to want the array that we're going to get from now is states array. The index is going to be I, and the object that we're going to write out to is going to be state config, right? And I suppose we should probably assert that too. because theoretically, these arrays can have any type, right? So if we try to get a type that isn't an object, that's going to bleat. Once we have that, then we can extract the properties from it. So let's just do a k-assert message here as well. And I'm going to do, I guess we don't need all this cleanup stuff, right? I could just assert, honestly. That's fine. So we want to do kson object property value get string as kname. So we want to get that from state config. The name we want is name, and the out value is going to be the address of a state's sub I name. And then the message, if the assertion fails, will be name is a required avatar state property. All right, so we're going to have a few things that are going to go to this a states sub I. So I'm actually going to go here and do a avatar state. I guess I could do we have, no, it's already used there. Okay. Sure, AV state. Okay. Equals the address of a states sub I, right? And now I can do AV state without having to do all that. Okay, so name is required. Animation name is not required. So I'm going to do copy pasta of that above line, but we're not going to assert it. So this is going to be animation name. And this is going to be animation name, right? So this is optional. Okay. And then really it's just this list here, right? So it's going to be kind of this same process over and over again to obtain that list. So from, is there a I don't think we would ever want a state that didn't have at least one from. So I think we should probably require that as well. So we're going to do a kson array again. And we're just going to call this from configs array. And that's going to be that. And then we're going to do a k-assert message again, and we're going to do a kson object property value get array. The object we're getting that from is going to be the state config. The name is going to be from, and the out value is going to be the address of from configs array, and the message is from array of states is required for an avatar state config. Okay. So once we have that, then we'll do a U32. Well, actually, we do have from state count. Okay. So let's do a k-assert on this. We don't need a message for it. Let's do kson array element count get. We're going to want to do that against from configs array. And the count we're going to set to, or we're going to put that in, rather, the AV state from state count, right? And then from here, again, we'll do a for U32. This time, I guess we'll say S for state, right? Or F for from. F equals 0. F is less than AV state from state counts plus F, right? And in here, then we can go ahead and just extract all of these names, right? So what we'll want to do here is we'll want to say, let's see, AV state from states, which is just a array of k names, right? So that we can actually just do kalloc C array, k name, oops, try that again, k name, AV state, from state count, right? And then all we have to do is in here, this becomes really easy. We can do kson array element string get as k name, okay? And so the array that we're going to get that from is the from configs array. The index we want is going to be f, and then the out value is going to be the address of AV state from states sub f. And I suppose we could assert that too, just to make sure, whoops, just to make sure that everything goes where it needs to. Okay, and so that is it, right? That is all that goes into deserializing. It's not really all that crazy. That's our complete deserialization routine. The only other thing that we're going to need is to load up those function names. And so we talked a little bit about, how that might be formatted. And so I guess probably what we should do is once we get this far, we'll just loop through the states, check each state and see if there is an existing function in the game code lib to be loaded into a PFN. Right? So again, we'll do, let's see, for U32 I equals 0, I is less than a state counts plus I. Right? And now we'll actually have to go through and do a little bit of string formatting, right? So we'll do on enter name, right? And that's going to be string format. And we're going to want avatar underscore string underscore on enter, right? And so this is going to be kname string get, and we want a name, right? And that's how we're going to do that. And then let me think. How did when we actually loaded, when we did this app game library, we're basically going to use load function let's see, dynamic library. We might have to extend this a little bit. So our dynamic libraries, we have the capability of extracting the function names out of them, or the function pointers rather. But in this case, they are actually kind of saved to this functions array, which is not really what I want. So we might have to actually modify that a little bit. Let me catch up on chat. What am I working on today? State machine? Yes, working on a state machine. So we just finished up the parsing of all of this stuff. And now basically what we're doing is for each one of these states, we're basically going to have a there's one step I forgot. Let me do this while I'm still thinking about it. Avatar. There's one more piece that we need in here, which is going to be the it's not going to be the A name. Well, it is going to be that, but also the K name string get states sub I name. There we go. So this will load something like avatar player idle on enter. So we're going to have basically the ability to set up functions in our game code that if they are named the correct thing, they will automatically line up to this. We'll have one for on enter, one for on leave, and one for on tick. And then we'll be able to set up function pointers to those things simply by name and simply by them existing in code. And that's kind of what we're working on right now specifically. You're the only person I ever see using GoTo. GoTo is goated for stuff like this, right? It has its use. People are like, oh, I never use GoTo. Well, yeah, I mean, GoTo can screw things up, but like, if you use it wrong. But if you don't, like it has its place, right? Like all these other failures up here, why would I want to, have this logic repeated up here with then a return and all that other stuff, right? When I could just go, oh, I've hit an error, let me bleat about it, and then bump down to here. And then I'm going to need to clean up whether it's a success or failure. And I'm going to need to return whether it's a success or a failure, depending on, a null or the actual thing itself, right? So use the right tool for the right job. All right, so let me put a left off on here. Load PFNs for enter, leave, tick, load from platform layer. And that load function It does actually return it to me though. Maybe that isn't. Maybe that is all I need to do. Maybe I just need to call this. Right. So the idea here is I would call this include platform H. And then it would be on enter name. And I think it would be, do we have the application here? We might not. Okay, so when we create this, that's going to be interesting. Okay. So app game library, and that's the application. Okay. So when we create this, I'm going to also have to pass in this. And then in the state here, struct application app and struct application and that's going to have to come in here as well. Struct application app. Right, and then here states app equals app. The reason for that is down here we need state app game library. Maybe need the address of that. Okay. So this is basically the way that this is going to work. Is we're going to say void pointer pfn equals this, right? And then if we have pfn, then we're going to say a states, which I should probably change that, but we'll do a states and then on enter equals pfn. Right? And that is how we're going to handle that, right? So whenever we set these up, we're basically going to say, hey, does a string with this name exist? If it does, go ahead and use that as our particular entry point there. And then, of course, string free on enter name. Right? Cool. So essentially just, you know what? I was going to say, let me just, since we have, let me just do this for the other two. Let me do, actually, we don't even need this check because that's going to return. You can simplify this to just that. Right, so we have on enter name. I could, I suppose, split this out into a separate function. Do I really need to do that though? I feel like I could just do it all in line. We only have 3 of them. So leave, 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 and then one more leave, right? Yeah. And then I guess I can just copy this again and do. So this is going to be tick. Right. And there we go. Okay. So, theoretically, we could have a state that does none of those things, right? Or any mix of those things. But that's basically the way that that's going to work. I feel like since we have the animation name, you could potentially have that where it doesn't, where it potentially doesn't have any of these functions. I think that makes sense. One more thing, I forgot about a rule up here. Kassert AV state from state count is greater than 0. Cool. All right. So that's some decent progress, actually. This is the basics of our state machine. We've actually got most of this set up. So the next step of this is going to be essentially hooking this into our application or our game code, getting this to initialize, and then we've got the parsing done. All we'll need to do is actually hook up the loading of this somehow and go from there. And to getting that incorporated into the scene. Pretty good progress, I think, for today. Not mad at that. And I believe I don't think we did anything in Kohi. Yeah, this has all been game code. Status. Yeah. So and gets commits. We'll do work in progress, avatar, system, state, machine. All right. So with all that said, it is, k-null, what is that defined as? Just 0. Literally just 0. I started doing that because I had lots of places in code where I had like counts were like 0, and then I also had like using 0 as null. And this way it's technically the same thing, it's just a little bit more explicit. So that's all that's really doing there. Nothing crazy. All right. So I think this is where I'm going to leave it for tonight. I'm going to find somebody to raid. Why not null then? I don't know. No reason. I could have used it. I have my own things to find for most things, so I just kind of did that here too. Let's see. Let me see if I can find somebody that is doing something kind of related, maybe. If I don't find something related, I'll just, pick somebody at random, I think, but bear with me just a second here while I look. Vibe coding, I don't think I'm going to go that route. Let's see. I guess what we could do open source brainstorming C++. Yeah, let's see what's going on over here. All right. Yeah, so that's going to do it for tonight. Thank you guys so much for being here. I appreciate you guys. We made a lot of good progress tonight. We'll make more progress tomorrow. And yeah, if you haven't already, I would greatly appreciate a follow either on the Twitch side or the YouTube side, or if you're so inclined to both. Helps me grow the channel. But anyways, thank you guys for being here. Appreciate you guys, and I'll see you guys on the next one. See ya.